Hey, everybody, this is part two of a three-part series about how to handle kind of the chapter challenge supporting documents. There are four parts to the entire thing, and we're going to be going through parts 1 and 2 in 3 video segments. I've already done one video. This is going to be the second one. I've been trying to make this video in the middle of office hours and keep getting kind of bumped off on the rest, or it would have been up sooner. Apparently, I'll have to do these videos in the evening instead when I'm not trying to converse and help other people. But that's just letting you know why it wasn't up more quickly. So let's go ahead and talk through this scenario and make sure that we understand how to create the data tables for it, because that's what the second video is all about. So to remember, this is the scenario itself, saying that the car is at rest on the left-hand side of the frame, and it begins to accelerate to the right. It then accelerates for 1/3 of a second until it's going 60 centimeters per second. And it stops accelerating and continues to the right at 60 centimeters per second. All right, so what we did in the last video is we did our conversions up here at the top, going from kind of the regular kind of physics class or real world to stop motion animation type of speeds. And we did the same thing for kind of time, eventually getting down here and saying, okay, here's our acceleration in centimeters per frame squared, and also how far the car travels during that acceleration. So those are all the pieces that we've already done. And now I'd like to come down here to this data table. Now I've started filling some of this in already. I'm going to delete it and show you where these numbers came from so that we don't get confused. All right, well, let's show how these things get filled in. First off, we're not going to need this data table over here on the right, only the one on the left. So this is where it comes. A good starting point to this puzzle, right, is to go ahead and say, well, what is my acceleration, what is my velocity, and what is my position right at the beginning? And I'm going to go ahead and say that let's call the position of the car 0, and the car starts from rest, so its velocity is 0, right, as we're coming into it. And then the next piece to this puzzle is what's the acceleration? Well, the acceleration, we actually calculated up here, right up here, where the acceleration is happening for 10 frames, or excuse me, 10 centimeters. No, it's 10 frames, and it travels a total distance of 10 centimeters during that acceleration, and the whole thing is 0.2. So I'm going to put in some pieces that we know here, where the acceleration is 0.2, right? And we know that this is going to happen over 10 frames because we know the acceleration is going to happen over 10 frames. So it's going to stay 0.2 the entire time those 10 frames of happening, right? So the acceleration doesn't change. Its velocity is speeding up by 2 centimeters per frame for 10 frames. The other thing to know is that after those 10 frames, the car is traveling, or should be traveling, at 2 centimeters per frame. We should also know that after those 10 frames, it should have moved 10 centimeters. So these are nice to put in here at this point to be able to say, hey, am I going to figure this out to make sure that it ends up in the right places? Now, in the acceleration category, just for entertainment's sake, it does say that after it accelerates for 10 frames, right, that 1/3 of a second, then it no longer accelerates anymore. In fact, it just travels off at a constant velocity. And that means that my acceleration drops to 0 for the remainder of the video, all the way down. Well, if my acceleration drops to 0, what happens to my velocity? Does it also drop to 0? No. It just means it's not speeding up anymore, and it's not slowing down. So it actually stays at 2 all the way to the remainder of the film, right? Whereas we're going, there's 2 centimeters per frame all the way to the end of the film. So we're still trying to fill this in. I don't really have other information except for this piece there, but let's go and take a look at the velocity here and help us out. Now, if the velocity starts at 0 and we say that it accelerates by 2 centimeters per frame, every frame, it just means that we're going to speed up by this amount each frame. So if I start at 0, then this next frame down the line is going to be at 0.2 because I've now sped up by this amount. So I've gone up by that amount. And then the next one, I'm speeding up by the same amount again. So that's 0.4, and then 0.6 and 0.8. and so on along the way, where our velocity increases by zero point 0.2 every single frame all the way through those 10 frames. I missed something here, 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8. No, we're good. And now it's up to here to 2. Everything looks good. We're speeding up to that. Seem to match up. That's good. All right, so let's go ahead and see what happens with this last one. This is position. Now, the position is the hardest part of the whole thing because we have to use this funny little formula up here, which is that 1/2 at squared plus our initial velocity times time. Now, my initial velocity is 0, which means that this other piece here doesn't even need to worry about it. I just need this beginning part, 1/2 at squared. That's the only part that I need. So let's plug in some pieces here to help me out. Where the 1/2, I'm just going to abbreviate that as 0.5, right? That's 1/2, 0.5. My acceleration is 0.2. And then my t squared. What am I going to use for t? Now up above, when I wanted to know kind of what happened in frame 10, I used 10. But now I'm in frame 1, so I'm going to use 1 squared. But be careful here. This square only affects the 1. It doesn't affect the 0.2 or the 0.5. So I don't need to square those pieces, just the 1. And if I'm simplifying this, 0.5 times 0.2 is 0.1. And 1 squared is 1. And 1 times 0.1 is 0.1, which means that in frame 1, my car needs to be at a position of 0.1 centimeters, which is 1 millimeter. So I need to put the car at 1 millimeter. In the next frame, we're going to do the same thing as before. We're going to say 0.5, that's the 1/2, times the acceleration, which is 0.2, times now the frame that I'm in now, which is 2, and I'm going to square that. I don't have to worry about that initial velocity stuff because it was 0. So 0.5 times 0.2 is nothing more than, again, 0.1. But now 2 squared is 4. And 4 times, that should be 0.1, not 1 point. 4 times 0.1 is nothing more than 0.4. Okay, this is good, this is good. So let's keep going the same way. 0.5 times 0.2 times the frame I'm in, quantity squared. Same thing we've done before, where 0.5 times 0.2 is 0.1, and 3 squared is 9, and 9 times 0.1 is nothing more than 0.9. Now you might see a pattern here if you're looking at these and looking at those, and if you can see it, that's great, because my next one is 1.6. Now how did I get that? All right, let's look. 0.5 times 0.2 times 4 squared. So 0.5 times 0.2 is 0.1. 4 squared is 16. And 16 times 0.1 is 1.6. Now we've got 2.5, 3.6, 4.9, 6.4. I'm just taking the frame number and I'm squaring it and multiplying by 0.1. And there we are. And by the way, that would be here 10 times point, or 10 squared times 0.1 does give us 10. But what do we do next when we're getting down in here? My acceleration drops to 0, which means that at squared bit doesn't mean anything more. But I am still moving forward at 2 centimeters per frame, which means that every frame I'm moving forward by 2 centimeters every frame. All I'm doing now is just I'm adding in that 2 centimeters along the way. And so on, right? So that's what I've got. And I can keep this process going where these are 0 all the way down. Each one of these is nothing more than 2 all the way down. And these numbers here just go up by 2 every time. And that is the entire data table. All right, I'm going to take just a moment and switch videos, and I'll show you how we can graph something like this. All right, everybody. Take care, and I hope this helped. Bye.